So on page 86, we're looking at changing the intervals on a graph. So what that means is we're actually going to be adjusting the intervals on the graph to help us describe different elements of the graph itself or find different information. So the problem is Maggie plays a board game, and each turn she rolls 2 dice to determine the number of spaces to move. She wonders which sums are most likely to be tossed. She uses an online simulator to roll 2 dice 1,000 times. Her table on the right-hand side shows the results of those online rolls. So she's rolled 1,000 times, virtually, and then recorded the data in a table. How can you change the intervals in a graph to help you answer questions about the data? So what questions are we trying to answer? We're going to get to those. But for part A, it says you have to enter Maggie's data into a spreadsheet, or graphing software. So we've been using Google Docs. So let's open a Google Doc and put the data directly into a spreadsheet. So in case you forgot how to do it, what you would do is go to your Google Drive, click Create, and then create a spreadsheet. When you create a spreadsheet, you want to give it a name. So I called mine Page 86 Model Solution, and then I grabbed the information from the chart in the question, and I manually entered in the values for sum and for rolls.
Good morning. Please excuse.
The next thing it says to do here is to create a graph. Now it says that we need to justify the choice of the graph. Down here right beside it. Now we have to create a graph using the 11 sums. 11 sums. So there's probably 11 sums in here. We can double check, but I'm positive there's 11 there. So what type of graph are we going to choose? So let's make one and then justify why we've chosen that graph in particular. Okay, right now what I'm thinking is if I'm going to show 11 sums, that's quite a lot of information. I might want to try a bar graph because then I can clearly see the different heights of each section. Might not want to try a line graph because the information would tend to blend together, be harder to interpret. Pie chart, no, these aren't percents, so I'm be less likely to try and use a pie chart. A pictograph, I could, but how would I show there might be quite a lot of pictures because some of them have quite a lot of number of rolls. There's up to 190 for some 7. So I think I'm going to go with a bar graph and let's see what it looks like. Okay, so the first thing that I noticed was that when I started with my data here, sum and rolls, and I try and chart it, well, I get a variety of different information. Well, in this one, the sum is just coming up like this. That doesn't make any sense. I highlight sum and roll. I try and build it into a table, and I get 2 different bars. Now, ideally what I want to happen is I want sum represented on one axis and roll represented on the other axis so that my bars can show a comparison between the two. But right now, it's just giving me a scale up the y-axis and putting both sum and roll along the x-axis together, and I don't want that to happen. So the way to change this using the Google Doc spreadsheet is to, well, analyze the sum numbers. You'll notice that sum starts at 2, 3, 4, 5, 6, all the way to 12, but if you look at the axis over on the left-hand side, going down, all these numbers are exactly the same as the values in sum. So if we were to get rid of the sum column and then move rolls with the values into column A, then highlight rolls and then create a chart, well, now you should be able to see more clearly that all of the roll values are represented by the bars. So the legend we kind of don't even need as long as we label the horizontal axis. And the y-axis values represent what? Well, what were we trying to compare? The 2, the 3, the 4, the 5, the 6, 7. Or were those the rolls? Do you remember? What were the values on the y-axis? What do they represent? See, if you look, that the highest value is almost 200. Would that be the number of rolls, or would that be the sum? Right, so the number of rolls would be on the y-axis, and the sum on the dice would be along the x-axis. So if you were to count the bars, the first bar is 2, the second one is 3, 4, 5, 6, the highest bar is the 7. 8, 9, 10, 11, 12. Well, I guess it makes sense. So now we can finish organizing the chart. So right now I'm putting in the title, and then I'm going to put in my headings. So the heading for the horizontal axis would be sum on dice, and then the vertical axis should be number of rolls. And do we need the legend? Nope, so we can take that out. So that should be a graph that represents the data. I hope that makes sense. Okay, so to justify the graph choice, well, what I've done is I've gone on to the Google spreadsheet and created a variety of different graphs. So here is a line graph created from scatterplot where the points are just connected into a line. Why might I not choose this one as opposed to a different one? Well, it's, I mean, if I look at the horizontal axis, there's no clear definitions of what's what. And if I check up the y-axis, I've got there are values. I can determine how much the highest point on the peak is approximately, but what I can't tell is what each roll is offering. So this type of a graph might not give me a clear determination of what each sum is providing for a number of rolls, meaning I might not want to use this one. Here's another one. This is a pie chart. Now this pie chart has been created in such a way that I have percentages of different sections related to different rolls, but it doesn't tell me what each roll is in terms of percent. And there are sections of the pie that aren't even shown. There's no percentage written in them. So this is not necessarily the clearest way of representing. With some tweaking I might be able to use this, but the way it's shown I really can't do anything with it. This is an area chart, which is similar to a line graph, only we identify the changes in area underneath each point as we create an areaed section underneath the spot represented by the points of each roll, or of the rolls in total. So the greatest area would be represented by the largest number of rolls for that sum, which is shown up here at the top. This could be useful if I was ranging or putting sections together. But if I wanted to determine the total number of rolls per sum, this wouldn't be the best option. So as a result, I would most likely go with this bar graph because I can easily put in a scale along the x-axis to tell me what each bar represents as far as the sum on the dice, and I can clearly see which dice sum gives me the greatest number of rolls. This is an even better representation because, as you can see, it still has a similar title. But the benefit here is that the legend shows you what the sum of the dice is in each case, and they're color-coded too. Google Spreadsheet auto-color codes them. So when I say sum, that means when you roll 2 dice, the face sum is shown here. And the number of rolls shows you the frequency of the sums when they're landed upon. From the graph, the color in the bar that's most likely to be hit on each roll is the 7. Why? Because it's the highest bar, meaning the number of times we hit 7 is the highest. So the probability of getting that as a sum is greater than all other possible sums, as shown in the graph. So it says in part C to make a prediction based on the card shown. Now the card is right here. So if you were to combine your graph into two sections or adjust your intervals, so 2 to 6 is one interval and then 7 to 10 or 7 to 12 is another interval, what do you think it would look like? So that means you would have to combine these values and combine these values. Well, visually, I expect that this section or this bar created from all values or all sums 7 or greater would be bigger. That's my estimation. And then everything from 2 to 6 combined should be a smaller bar. Let's check it out. Okay, so to use Google Spreadsheet to create the second section of the graph where you combine intervals, what you would need to do is create a new title, so sum on dice, 2 to 6, 7 to 12, so I'm creating 2 new intervals. For the first interval, you have to program into the software how to calculate sum, rather than adding up all the values yourself. So the way to do it is you type in equals, bracket, and you tell the computer which cells to add up. So we start at cell 2 and highlight all the way to cell 6. Close your bracket, push enter. Now you'll notice something happened. Why didn't it accept the error, or why did it create an error and not accept the values? We have to give it an instruction. We have to tell it to find the sum. So equals, tell it what to do. Sum, bracket, 2, 6. So you're telling it to find the sum of cells B2 all the way to B6. Close your bracket, and then it will calculate. Do the same thing for the second section. Equal sum, 7 to 12. Make sure you're highlighting the proper sections. The sums are done. Now it's a matter of creating the graph to prove your estimate was actually accurate. Okay, so for the next section it says, make a graph to check your prediction. Well, I took this chart and I created this graph. And as you can see, the game options or the sum options are here. So if I could throw that title into, I should. This bar represents free turns, because as you can see the range is from 2 to 6, and this represents lose a turn, because it's from 7 to 12. So we checked the prediction. Now, if we go back and check, I thought that the second bar would be taller than the first bar. The reason I thought that was because as you can see here, the 7, 8, 9, 10, 11, and 12 sections seem to be combined to create a bigger sum, or a bigger total number of outcomes, as opposed to the 2, 3, 4, 5, and 6. So that's why I thought the second bar would be bigger than the first bar, and it turns out that it is. So my prediction was correct. Okay. So next, it says here, how can you use your graph in part C to determine whether the probability of getting a free turn is greater than the probability of losing a turn? Well, it's pretty straightforward. The probability of getting a free turn is from 2 to 6. And since the bar is lower or smaller, that means the total number of rolls in which this occurred is less. So we're more likely in this game to have an outcome of 7 to 12. That means we're more likely to lose a turn in this game. Here's an interesting creation of the graph for the next section, where we're trying to identify the probability of gaining 5 points or losing 5 points. So if Maggie picked that card, what I did here was, let's see if I can. So this is the graph. graph that I created. So I put in the sum of dice, or sum on the dice, 4 or 5, 8 or 9, and then I did the same operations. You can see the calculation up here. So sum of B4, B5, that gave me 4 and 5. Because B4, and B5 are here. 63 plus 118. Now you can do those calculations manually, but you don't have to if you use the software to do it. Once you're in the graph, this makes it look like you're more likely to get an 8 or a 9, significantly more likely to get that than you are to get a 4 or 5. Now why is there such a huge discrepancy between the two? When if you look at the numbers over here in the chart, there isn't. Well, look at the scale on the y-axis. And notice how we've scale jumped up to 170. That has skewed the data and made the graph look differently, to make the difference between the two bars look very, very big. How can we switch it to make it look a little bit more realistic? Well, I'm going to do that in a second. Understand that if you scale jump, it could change or change the appearance of the data to make it look the way you want it to. So the way I reset the scale so that the bars actually look realistic, you'll notice that the difference between them isn't as big as it was meant to look before. I changed the vertical axis so it starts at 0. And the way I did that was setting the minimum value for the vertical axis to 0. So I typed in 0 and then I just clicked my mouse off of that bar and then the graph resets properly. Then you can click update and then it's ready to go. Let's move on to the next section. So according to the next question, it says here that Maggie picked this card. And we have to use a graph to determine which option is more likely. Well, option 4 and 5 is this bar, and it's smaller, meaning there are fewer rolls that had a 4 or a 5, and there are more rolls that had an 8 or a 9. Therefore, we're more likely to lose 5 points every time we roll than we are to gain 5 points, according to our graphing information of 1,000 rolls. So in the reflecting question, the questions are straightforward. Describe how the appearance of the graph with intervals changes for each situation. So when you increase the size of the intervals or when you decrease the size of the intervals, what happens? Well, let's have a look. So here, we've got two graphs representing information. This graph here shows that there are many intervals. So when you increase the number of intervals, the graph looks a little bit busier. There's a lot of information on it that's separated. Now it's important to have information separated at times so that you can specifically identify different information. However, when you're trying to convince someone of an argument or convince someone in general of a relationship, like in this graph where it talks about is it possible, what's more likely to get 5 points or lose 5 points, you can combine sets of data. So we combined 4 and 5 to create this bar, and we combined 8 and 9 to get this bar in order to compare the likelihood of getting 5 points or losing 5 points. And again, so according to this, is it better to combine the data, or is it better to leave the data separate? It really depends on what you're trying to do. We leave the data separate when we need a specific answer. We combine the data when we're trying to show clearly a general relationship. Now, I say clearly because the bar differential is very obvious here, of which one is higher, which one is lower. When there's a lot of bars, it might be harder for the viewer to find the difference you're talking about. So it might be important to just pinpoint or combine bars to create a general graph like this with fewer intervals. So fewer intervals makes the graphs simpler to view and simpler to understand.